Hi students, in this video we will be looking at the chemical bonding worksheet 1 and it is expected that you should have done your worksheet. So in viewing this video you will be able to look at the answers and do please take out a green pen and do your corrections accordingly as I go through the answers. Okay, let's get right into it. Okay, so this is chemical bonding worksheet 1. Okay. Okay, so this worksheet is for all Sec 3 Express as well as NA students. So for a start, let's look at question 1. You are required to complete the following table. So as you can see, right, this table is split into two parts, atoms as well as ions. So perhaps let me just take this opportunity to quickly remind you of what we have been talking about since the start of Sec 3, which is this term called particles. Okay, so particles is a very general term that could mean, more specifically, atoms, ions, as well as molecules. It's just like how science is a general term to refer to, let's say, chemistry, biology, and physics. Okay, so atoms, as we learned in chapter 5, atomic structure, we know that atoms, they are electrically neutral. Okay, so think about it. Why are atoms electrically neutral? Why do we say that they have no charge? Okay, that is because the number of protons that they have equals to the number of electrons. So number of positive charges equals to that of the negative charges. So that's why atoms, they are electrically neutral. Ions, on the other hand, they are charged particles. Okay, charged particles, because when you form ions from atoms, you are losing or gaining electrons. So ions, definitely they have to be charged. Okay, so let's go back to question 1. So you can do your marking on your own, okay? Do your corrections. So over here, we need to look at symbols, electronic arrangement, proton and electron numbers for the various elements, okay, as I have pointed out. So perhaps we can have a look at sodium, okay? So sodium, if you were to just look at the grand scheme of things, right? If you follow through with my train of thought, for this particular chapter, we always talk about things at a symbolic level first, meaning looking at your periodic table, what are some of the symbols as well as data that you can get out of it, right? Basically, what you can get is the number 11, which is the proton number, and 23, which is the mass number. So moving on from this symbolic representation, we can move on to this thing called the electronic configuration. Okay, basically, how do you configure the electrons and put them into electron shells? So for instance, for sodium, it's 2.8.1. First shell has 2, second shell maximum 8, and then the spillover one will be in the third shell, which is the valence shell. So we can take that one step further, and we saw that in chapter 5, where we can represent this in a diagram. So that will be called the electronic structure. So really drawing out the electron shells, 2.8.1. Okay, it's a bit ugly, so let me draw it again. So we start with the symbol in the middle. We draw the first shell, which can contain a maximum of only 2 electrons. And then after that, second shell. In this case, we can fill up to a maximum of 8. We maximize that. Okay, 8 electrons in the second shell. And then we have one more, right? So that would be the third shell. So we'll draw one more circle to represent the third shell. And we can put that 1 electron there. Okay. But the story is not ending there. So for chapter 5, it ends here. But since now we are at chemical bonding, we bring that understanding further to talk about bonding, right? So there are two types of bonding that you need to learn for combined science. Okay, so ionic as well as covalent. And then of course, the pure chemistry students, there's another one which is metallic bonding. And then finally, to link bonding to physical properties, which we will cover in another video. Okay. All right. So now going back to the main question, let's look at sodium, our good friend, as the main example. Okay. So let me bring your attention to the periodic table again. Let me just zoom in and let's look for sodium. All right. It's right there. Sodium is right there. Okay. And let me change the color. Now, so in the periodic table, you know that sodium is in group 1, okay, in Roman numerals, group 1, and it is in period number 3. So now, this is very important. You need to know how to use the periodic table. This is a trick that you need to know. So group number tells you the number of valence electrons, meaning how many electrons are in the outermost shell. Okay, whereas period number tells you number of electron shells. How many shells are there in total? So for instance, sodium is in period 3, so I will know that sodium atom has 3 electron shells. So 1, 2, 3. And because I know that it is in group number 1, that tells me that it has 1 electron in the valence shell, 1 valence electron. So I put a 1 there. So I can safely also say that the inner shell electrons are all fully filled. So the first shell can put 2, and then second one is 8. Therefore, sodium atom has an electronic configuration of 2.8.1. Okay, great. Let's move back. So, okay, you can check your answers. There shouldn't be much issues for atoms. Based on experience, usually students have more issues when it comes to ions. So let's talk about ions a little bit more. Okay, so again, in forming ions, right, from atoms, what will happen is that your atoms will either lose or gain electrons, right? Metals will lose electrons, non-metals will gain electrons. And why do they even want to do that? Okay, what is the motivation behind? Okay, it's these 4 golden words. So for instance, sodium, right? It has 1 valence electron. It doesn't like that. It wants to be like the noble gases, okay, by achieving the stable octet electronic configuration. Okay, stable octet or duplet, but most of the time is octet. Duplet usually is lithium, as well as hydrogen wanting to be like helium. Okay, the rest is all octet. Yeah, so sodium will lose that 1 valence electron in its outermost shell in order to achieve the stable octet electronic configuration. And because electrons are negatively charged, if you lose one negative charge, your final state will be a 1 positive. Okay. Next, proton number. Proton number, it should remain the same as 11 because proton number, as we have mentioned, is just like your NRIC number, right? It doesn't change. It's tagged to you for life. It's unique to you. Okay. So again, if we bring back the periodic table, we have a look at it, right? Notice that uh, the proton number is all unique, correct? It's all unique. There is no repeat of the proton numbers at all. So in fact, if I were to say, oh, okay, can you help me look for the atom with proton number of, let's say, 15? Immediately you can zoom into phosphorus and tell me that that is the atom that I'm thinking about. That is the element that I'm thinking about. You get what I mean? It's unique. So for ions, I guess the only thing that you really need to take note is the electron number. Okay, because like I said, in forming ions, you gain or lose electrons. So you need to count very carefully, and most students will get it wrong at this part. Okay. Yeah, so please do your corrections accordingly. So for instance, sodium, magnesium, and aluminium, it has valence electrons that they want to lose, whereas for the non-metals, they will gain electrons in order to achieve stable octet. Okay, so for instance, chlorine becoming chloride, oxygen becoming oxide. Okay, so that is question 1. Let's go to question 2. Question 2. Here it is. Okay, let's get into it. So question 2, again, you have a table to complete. Now the focus of this question is on naming of ionic compounds as well as your chemical formula. Okay, so chemical formula is really something that a lot of students struggle with. So if you follow through with me, you will be fine when you go to Sec 4. Okay, so ionic compound made up of 2 components. First part is a metal. Second part comes from the non-metal. So for instance, sodium chloride, the metal is sodium, the non-metal is chlorine. So yeah, you will get the positive ion as well as the negative ion. Okay, so this part, perhaps I will just, oh yes, let me tell you first. The whole idea about getting chemical formula correct is number 1, you need to know how to balance the charges. It's so important. Okay, so after getting the formula for the positive ion and the negative ion, you need to do an extra step of balancing the charges first before figuring out what is the final chemical formula for the ionic compound. So perhaps let me just choose the most difficult one out of this list, which is aluminium oxide. Okay, so the metallic component is aluminium. The non-metal is oxygen. So aluminium has electronic configuration of 2.8.3, oxygen is 2.6. So aluminium, in forming the cation, it loses that 3 electrons. Sorry about that. Loses that 3 electrons, okay, and then it forms Al3+. Okay, so that will give him the octet 2.8. Oxygen, on the other hand, it will gain 2 electrons to give oxide ion O2-. Okay, so now both of them have the octet configuration. Okay, so now, so far so good. Now is the important part. You need to know and learn how to balance the charges. So what do I mean by that? So for instance, the cation Al3+, you can think of it this way. 1 unit of your cation gives you 1, 2, 3, 3 positive charges, and your oxide anion gives you 2 negative charges. Okay, so ask yourself, currently the charges are not balanced yet. Okay, so you can actually use your mathematics concept of lowest common multiple, in this case is 6, okay, in order to balance the charges. So how does that look like? For the cation, now you have 3, so to become 6, you need to multiply by 2, by a factor of 2. And then the anion side, you multiply by a factor of 3 to again get 6 negative charges in this case. So now it is balanced, right? So how do you write the final chemical formula? Al2O3. Done. Simple. Okay? If you can do this, you are a winner. Chemical bonding is a piece of cake. So I just wanted to point out that for part G, zinc, because zinc is a transition metal, you don't really need to know how it gets the cation, as well as silver. Okay, so for these two, you just memorize. Zinc cation is Zn2+, silver cation is Ag+. Okay? Yep. Okay, that's it for question 2. If you are feeling okay, then we will move on to question 3. Otherwise, you can pause the video and look at your answers again. Do your corrections. Okay, I will see you in a bit. Let's continue with going through the answers for question 3. Okay, question 3. Alright, let's go. Question 3, complete the following table which gives information about two ions. So here you have F minus as well as Mg2 plus. So F minus is the fluoride ion, and then magnesium is the magnesium cation. Okay, so for this question is really very easy. Basically, again, you need to go back to your good friend periodic table, take out the information that you can get from there. So for fluorine, you would know that the proton number is 9, mass number given is 19. Okay, so that immediately you will know the proton number. And now to figure out the number of electrons, which again I say is very crucial, you need to figure out that because fluoride anion, it has gained 1 electron already, so you need to take 9 plus 1 to get 10 electrons for the fluoride anion. Okay, so therefore answer is 10 for number of electrons. Nucleon or mass number, just remember the formula, which is number of protons plus number of neutrons. So 10 plus 9 is 19. Moving on to magnesium cation. So again, looking at the periodic table, we know that the two numbers are 12 and 24 respectively. So therefore, we know number of protons is 12. Number of electrons is given in the question in this case, but you should be able to figure that out as well. So that's 12 minus 2, right? Because magnesium is 2.8.2. In order to achieve octet, it will lose the 2 valence electron to form Mg2 plus cation. Okay, so after losing 2 electrons, it will be left with 10 electrons. Okay, alright, move to question 4. The diagram represents the arrangement of electrons in a magnesium atom and oxygen atom. Complete the table. So, okay, this question, what you can do is, since they give you the diagram, you can make good use of it. So for instance, if we look at magnesium, right? Number of protons. How do we know how many protons? Obviously, the quickest way is to look at um, the periodic table, right? But another way to use this particular diagram, using the what's given to you, is to really look at number of protons equals to number of electrons, right? You can count the number of electrons. So in this case, in orange, I'm counting, right? So in total, there are 12 electrons for a magnesium atom. So using that equation, you know that number of protons is also 12, number of electrons is 12. Okay. Then to figure out number of neutrons, you just take mass number 24 minus 12. It is also 12. Moving on to oxygen, we do the counting again. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for oxygen atom. So that's why you get the 8 there. Number of protons, again, it will be equal to that, so 8. Electron arrangement 2.6. Now, at this point, I just want to make a note. This particular diagram in this question for oxygen is slightly not correct. Okay, so to represent it, I guess in a more accurate manner, it will be like that. Okay, so first 2 electrons in the first shell. Second shell, generally what I do is I put the first electron on top, then I go clockwise, 2, 3, 4, 5, 6. Do you notice that the diagram looks a bit different from the one given? Okay, so actually there's some reason to it lah. So if we go to covalent bonding, right, you'll realize that the oxygen atom that I drew is more correct, because once there is a covalent bonding between oxygen and the 2 hydrogen atoms, okay, to form water molecule, which is H2O, you will realize that my diagram will give you the shape that oxygen is in, okay, which we call it the bent shape lah, okay, and for higher level chemistry. Okay, so the so-called the Mickey Mouse shape, which you should be familiar with from primary school. Okay, so technically speaking, this diagram printed is not very accurate. Okay, doesn't matter. But move on. Next part, B. Magnesium oxide contains ionic bonding. Okay. Draw a dot and cross diagram for magnesium oxide, including all electrons in your diagram. Okay, so make sure you highlight that all electrons. Okay, so this question is 2 marks. All right, simple. But I just really want to run through the entire process, thought process with you. Yeah. So first things first, magnesium oxide, right? So again, split it into two. The first part comes from the metal, which is magnesium. Oxide basically comes from oxygen, which is the non-metal. Okay, metal and non-metal come together form ionic compound. So magnesium electronic configuration is 2.8.2, oxygen is 2.6. Okay, so it doesn't want to be in that state, right? It wants to be stable. So magnesium will lose 2 valence electrons to form Mg2 plus cation. Cation ions are positively charged ions. Okay, so octet 2.8. Oxygen, on the other hand, it will gain 2 electrons to form O2 minus anion, negatively charged ions, 2.8 octet. Okay, all right. So again, what is the motivation, right? Why does magnesium want to form Mg2 plus, oxygen want to form O2 minus? It is again that 4 golden words in order to achieve the stable octet electronic configuration. Okay, because it wants to be like the noble gas, the noble gases, right? Which is in group 0 with 8 valence electrons, very stable, fully filled electron shell. Okay, so that's the thought process. Okay, I don't have space anymore, so I'm gonna do some magic here. Make it smaller. Okay, very good. Now I have space, right? Okay, so let's carry on. So that's the thought process, okay, but we are not done. Okay, so we have thought about the electronic configuration. Now we gotta move on to electronic structure. So now we draw the structure, the diagram. So magnesium, okay, we draw one shell, put 2 electrons. Second shell, we put 8. Yeah, 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so we are drawing the cation. So take note that we need to put in the square bracket, and then the charge we put it at the top right hand corner, 2 plus. So that's done. Cation's done. So now we do anion. Okay, oxygen, write the chemical symbol, draw the first shell. Okay, at this point, it will be helpful if you do the legend. Okay, so again, because you're drawing dot and cross diagram, right? So, oops, sorry. Yeah. So magnesium, I have chosen the symbol cross, the cross symbol. Okay, so the cross would represent the electron from the magnesium atom. So naturally, for oxygen, I have to choose dot. Okay, yeah. So I draw 2 dots for the first shell, and then I draw my second shell. It should have 6 electrons. 1, 2, 3, 4, 5, and 6. Okay, why 6? Again, we go back to our thought process earlier on, right? Oxygen is 2.6, so the second shell should have 6 electrons. Okay, so 1, 2, 3, 4, 5, and 6. 6 electrons. So that belongs to oxygen in the outermost shell. Oxygen atom so far. Okay, so oxygen atom wants to achieve stable octet electronic configuration. What does it do? It gains 2 electrons. So these 2 electrons, right, for anions you need to be very careful because these 2 electrons, you need to understand that it does not belong to oxygen, right? It gains that 2 electron from the metal. Yeah, it does not belong to oxygen. So with that understanding, in your dot and cross diagram, this part is very important because a lot of students get it wrong. Okay, so these 2 electrons, you need to reflect the understanding that it came from magnesium. So you need to show using cross, the symbol, because it came from magnesium. Okay, So once you're done, again, draw the bracket, square bracket, and then put the charge 2 minus. 2 plus, 2 minus. In this case, it balances out very nicely. There's no need for like any math magic going on. So you are fine. Okay, so that's a double tick, 2 marks into your pocket. Cool, good. Okay, now I'm just going to do a quick recap on what are the things that teachers look out for when marking your diagram. So again, I'm going to do some magic, make this smaller because I need space. Okay, perfect. Change the color, maybe pink. Okay, now, so I highly encourage that you write this down. So take note of the following things, all right? This is what teachers look out for when we mark. Okay, so if you realize, right, actually there's a lot of areas where you can make mistakes. That's why a lot of students do badly also, all right? So number one, you need to draw the square brackets as well as put in the charge because you're drawing ionic compounds, right? Ions got charge, so you must put bracket, put the charge. Okay, that's number one. Number two, you need to make sure that your symbols is correct, right? Again, go back to the question. You are drawing dot and cross diagram, not dot dot diagram, not cross cross diagram. So you jolly well make sure that your symbols are correct. Question 3. Third point. Third point. So some students, they, okay, 1 and 2, no issues, they are fine. But come to number 3, they forget that now your ions, they are stable already, right? They already have the stable octet electronic configuration. So you got to make sure that your valence shell, it has 8 electrons. So just count lah, make sure that you don't make any careless mistakes. That's what I'm trying to say. Okay? Alright, we will go to look at part 2. Alright, so in part 2, we will okay, let's read the question. Explain fully in terms of transfer of electrons and formation of ions, the changes which occur when magnesium oxide is formed from magnesium and oxygen atoms. Okay, so yeah, it's a pretty loaded question, so just make sure that you annotate and highlight as I have done. Okay, so for this particular question, let me type out the answer for you. Okay, here it goes. So a magnesium atom, let me adjust a bit. Okay, so a magnesium atom loses 2 valence electrons, okay, to attain the stable octet electronic configuration, right? Because magnesium is 2.8.2, so it loses that 2 electrons. 2, okay, what happened? Thereby forming your magnesium cation, right? Mg2 plus. Okay, so that is for your magnesium atom turning into magnesium cation. So then what happens to your oxygen, right? An oxygen atom gains 2 electrons, okay? And to be more specific, it gains these 2 electrons from magnesium, okay, the atom, to form the oxide ion, the oxide anion, which is O2 minus. Okay, now let me just highlight for you to let you see where the marking points are. Okay, so again, number 1, you are looking at in terms of transfer of electrons and formation of ions. Okay, so this first part, magnesium loses 2 valence electrons, right? So you are addressing magnesium atom. First point will be it loses 2 electrons. So that's the transfer bit. Okay, and it forms magnesium ion, which is Mg2 plus. Okay, then moving to oxygen. Okay, again, in terms of transfer of electrons, now it is the gaining of electrons. So non-metals will gain electrons in order to form the oxide anion, O2 minus. Okay, yeah, that's it. Next question. Okay. Sodium chloride and magnesium oxide have similar crystal structures and both contain ionic bonding. Okay, so up to this stage, you should be familiar with the naming as well as the chemical formula already. So sodium chloride is NaCl, magnesium oxide is MgO. Okay, but even if you don't know, the question is helping you, right? It tell you that both contain ionic bonding. So both are ionic compounds. Then they go on to tell you more info that their melting points are 800 degrees Celsius and 2800 degrees Celsius respectively. Question asks you to suggest why the melting point of MgO is much higher than that of NaCl. Okay, so a very long question. And to be honest, I will just draw a very big star over here because this is what I call a hot question. Higher order thinking question. Okay, so if you don't know how to do this question, it's perfectly fine at this moment because it is a bit tougher. Okay, uh, that said, um, it doesn't stop you from being able to do it as well, because if you are very clear with the understanding of this chapter, then you shouldn't have much issues as well. So if we look at sodium chloride, right, we break it down again to the two components. It is Na plus, Cl minus, and then magnesium oxide, it is made up of Mg2 plus and O2 minus. Okay, so the ions, they make up the ionic compound. All right. Okay. Now, so because this is an ionic compound and it contains ionic bonding, all right, so there is the presence of ionic bonds. And very quickly, let's do a recap of what ionic bonds are, right? Ionic bonds, they are the strong electrostatic forces of attraction. Oh, oops, I clicked on something. I clicked on the home button. uh, Ionic bonds are the strong electrostatic forces of attraction between oppositely charged ions. Okay, so that's the definition, so to speak. All right, so yeah. So in this case, okay, back to the question, right? Talking about melting points. So why do they have such high melting points for ionic compounds? Okay, precisely because of this. The ionic bonds are so strong. Okay, so let's look at the answer, right? Suggest why the melting point of magnesium oxide is much higher than that of the melting point of sodium chloride. Okay, so you can begin the answer by saying that the charges on the magnesium and oxide ions, okay, are higher than that of the sodium and chloride ions. Okay, much higher, right? Because Mg2 plus O2 minus versus Na plus 1 plus and Na minus, Cl minus. Okay, so as such, the electrostatic forces of attraction between your Mg2 plus cation, okay, having a bit of a struggle with the font and everything, juggling between typing and writing. Okay, so as such, the electrostatic forces of attraction between Mg2 plus cation and O2 minus anion is therefore much stronger, right? Two charges versus one charge, definitely the the one that has two, is a lot stronger, right? So if we bring it one step further to talk about energy required to overcome these forces of attraction, surely you need more energy to overcome the strong electrostatic forces of attraction between the Mg2 plus and O2 minus ions versus Na plus and Cl minus. Okay, so a concluding statement would just be, hence, magnesium oxide has a higher melting point than sodium chloride. Okay, so like I said, this question is slightly more higher order thinking. Of course, for pure chemistry students, this is what is expected. But for combined science students, this is something that if you can understand, it's perfect. It means that you have a good grasp of this chapter. Okay, and that is something that we hope to achieve. Okay, so these are the important things that I'm highlighting. Charges higher, therefore electrostatic forces of attraction stronger, therefore you need more energy to overcome. Therefore, that particular ionic compound has a higher melting point compared to the other one. Okay. Part D. You have a diagram below that shows how aqueous sodium chloride can be tested for electrical conductivity. State the result you would expect to see, explain your answer. Okay, so I would box up this part which is on electrical conductivity. So immediately you should be able to know that this is a physical property. And that is the concept that this question wants to test you on. Okay. Alright, so again, let me show you the answers because you should have attempted this already, right? So basically talking about physical properties of ionic compounds, there are three, right? You know three. Uh, Solubility in water, melting boiling point, and electrical conductivity. So this is the third one. So your answer will be the light bulb will light up, okay, because sodium chloride, your ionic compound, dissolves in water. It is soluble in water, therefore it dissolves in water to form free moving ions, okay? And these ions are able to carry electrical charges, therefore it can conduct electricity in this setup. Okay, so highlighting the keywords for you, light bulb will light up, that's 1 point, 1 mark. So the reasoning is sodium chloride dissolves in water to form free moving ions. Okay, keyword is ions, not electrons, not molecules, not atoms, ions, because it's ionic compound. Okay, so yeah, in your diagram, it shows a complete circuit after you close the switch. And then, of course, in the beaker, your aqueous sodium chloride has free moving ions, so that will help you carry the electrical charges. Okay, then question 3, last question. You have an element X that forms an ion X2+. They tell you that this ion contains 54 electrons. For this element, you need to give part A its name. Okay, so before you can even figure out what name this element is, you need to know how to know what this element is, right? So you're given information that the element forms an ion. Okay, so again, back to our basic understanding, you're going from atom to ion, and in this case, your atom has lost 2 electrons, right? It loses that 2 negative charge, the electrons, that's why it ends up as a X2 plus. And they tell you that this ion has 54 electrons. So you need to do a bit of manipulation here, right? You need to add back that 2 electrons back to the atom. So then now you know that the atom has 56 electrons. And because number of electrons equals the number of protons for atoms, so you know that element X has 56 protons. That is the NRIC number, right? So if you go and see the periodic table, barium will have 56 protons. So therefore, option A, part A answer is barium. Part B, you need to figure out the group in the periodic table and then give a reason to explain your answer. So here, easy, right? You use the trick that I taught you. So it is in group 2. Okay, because why? Give a reason to explain your answer. It has 2 valence electrons. Oh, sorry, I pressed the home button again. I'm a bit sleepy and now it's almost 1 a.m. Okay, yeah, group 2. So group number tells you number of valence electrons. So that is your reason, right? Barium has 2 valence electrons. So therefore, in forming the ion, it will lose that 2 electrons to form a 2 plus kind of ion. Okay, finally, part C, the chemical formula of the compound that barium will form with chlorine as well as oxygen. Okay, so barium atom forms Ba2 plus cation. And then looking at the non-metal, which in this case, number 1, chlorine, it is 2.8.7, so it will gain 1 electron to form chloride, Cl-. And then oxygen is 2.6, it will gain 2 electrons to form O2- oxide ion. Okay, so again, back to the fundamental, as long as you balance the charges, you will get these two answers for your chemical formula of the ionic compound. Barium chloride, BaCl2, as well as barium oxide, BaO. All right, yes. Oh, this was a long video. Okay, yeah. So, yes. So to all my students, see you in the next lesson. Smiley face. Goodbye.